if you're doing experimentation or supporting experimentation, you better have pretty good monitoring of what's going on and what the performance is. So this um, mosaic here shows 4 of the tools we have. Inca is our main tool, which monitors the performance and stability of FutureGrid. Ganglia is also available. Persona for the networking, and Snap also for network monitoring. This is an area which, as FutureGrid moves forward, even more needs to be done. This slide here sort of summarizes in a rather complicated, rich diagram what FutureGrid is. Let's look at that. We have at the top, we have on the left the sort of classic stack for cloud: software as a service, platform as a service, infrastructure as a service, network as a service. Now this is slightly different from your normal cloud stack in that it includes bare metal. Namely, it says that we use the same as a service model, but we support classic high performance computing as well as or virtualized systems with hypervisors. We also, as we move towards software-defined systems and working with projects like Genie, we include network as a service in this stack because we assume that you're going to be defining virtual clusters at the IaaS and NaaS environment, or maybe I should even say virtual grids. Then you'll put your platform as a service. This has classic cloud platforms like MapReduce, where we put the high-performance computing platforms with Saga or Petsy, the well-known HPC library here. And you can also think of computer science tools such as those needed to support compilers or sensor nets as appearing at this level. And then finally, on top of that, of course, we have the actual software as a service. This is where the domain scientists will position what they're trying to use. And it just has all the applications. Then if you look at what FutureGrid has to support this, it uses what we've identified as testbed as a service tools, which are provisioning, image management, we'll discuss those a little later on, the infrastructure as a service systems and their interoperability, the network as a service tools, experiment management, that's an area we still need to make more progress. And I say the NAAS and IaaS should be dynamically instantiable. And you need to use good software engineering practice as you implement all of this. We have a system called RAIN, which includes Cloud Mesh, which is developed by FutureGrid to support this dynamic provisioning. It's an area that changes quite rapidly because the software we're building it on, like OpenStack, changes dramatically every 6 months. We're now up to the 6th major release of OpenStack called Grizzly. And that means that our software changes because each release has significant changes and it has significant added value, saying that something we developed for an earlier release probably needs to be changed or maybe even dropped for the next release. And so that's an area of rather dynamic activity where you really have to be aware of the state of the art. We have testbed as a service with FutureGrid, RAIN, and Cloud Mesh. We have a portal we've developed, which is now integrated with the Exceed project submission portal. I've mentioned the monitoring environments, Inca and Ganglia. We have the software and system development tools, Chef, Puppet, Salt, and we have experiment management where we are developing Pegasus to support the deployment of experiments and recording of their provenance to allow reproducible experiments. This slide describes some aspects of the RAIN system and the type of thing it's doing. It's doing dynamic provisioning. Dynamic provisioning can be divided in these 4 different phases. You first make your favorite image. which image is specified by just logically by an XML file, so it's so-called templated. So you design and create it, you vet its security, but then you do not store necessarily the image as rather a large number of bits and bytes, but you can store it as a template, because you've already shown that you can create that template. Then, so that's step B. Step C is to actually create the image and register it with a virtual machine manager, which is like Nimbus or OpenStack. And then step D is to instantiate it, which is the actual provisioning, to make it actually running on a FutureGrid node. And here we have some timings for different approaches. The blue here on the graph on the left is OpenStack. It's plotted against the number of machines you have to provision. The pinkish color is XCAT and MOAB, which is the current approach to HPC, high performance computing environments. We're going to remove our dependence on XCAT because it's not supported on all Linux environments. It is very good on the iDataplexes because it comes from IBM. So that's phase D. Because you have to boot the image, the time for the HPC environments are somewhat longer for smaller number of nodes than the virtual machine case. So that's why the blue rises with number of nodes. The pink has a fixed concurrent booting, which tends to make it roughly flat as the number of nodes increases. On the right, we have the timing for phase A and B, which is actually making the image and uploading it to the repository. And on the top right is actually got the various steps involved, and it's done separately for CentOS and Ubuntu. There's actually some significant differences there in the time taken to create the base operating system. That's this red one here. That's clearly different for Ubuntu and CentOS. And then we have here with the same color scheme. Well, here we have Ubuntu, which is the longer time, and blue, which is CentOS. That's when you're doing this concurrently for several images. So this is an area where we're still doing substantial work, and the software to support this will be released in a few months.